Welcome to Homework Lib.
So in the first part of this question, we have that the proportion in the sample is 0.15, and we have that the standard error is 0.025. So we want to know what is the sample size. So we're gonna use the formula for the standard error, which is given by the square root of p hat 1 minus p hat over n, knowing that this is 0.025, and here we have 0.15, and this is 0.85 to get the value of n. So by just isolating n, what we're gonna have is 204. Then for the second part of this question, you know in this case here that they are saying that 90% of the people pass the course, which we can assume this to be the probability of passing the course or proportion of people that pass the course. And you want to know what is the probability then that out of the 150 students, that less or equal than 129 will pass. And this here is, so saying that the number out of the 150 will be less or equal than 129 is the same as saying that this proportion here, which you're computing based on the 129, which is 0.86, will be less than. So we can write this in terms of the sample proportion. So now we can define that the distribution of the sample proportion is normal, with mean equals to the proportion that the professor said. And the standard error here will be, just like in the first question, given by this. So using this, we can use, because of the normality, the z-score approach to find that this probability is based on can be computed based on the standard normal distribution by computing the z-score for this value, which is given by this value minus the mean of the distribution over the standard error. Now, by computing this transformation, what you're gonna have is z being less or equal to negative 163, and using the z-table, this is 0.0516. Now for the third part of this question, if you know here, in this case, that the confidence interval was 1725 plus and minus 242, based on a sample of 40, you want to know now what will be the confidence interval based on a sample of 160. So in this case, what we need to do is, we know that this margin of error is given by a critical value times sigma over n here. So if we want to change this, I need to know what is this value, because it will remain fixed, okay? Then what we're gonna do is, we're just gonna multiply this here based on the 40 here to find that in this case 15305 is the numerator of the margin of error. So now if you want to assume that we have 160 instead of like instead of 40, what we're gonna do is just divide this by the square root of 160, and that will give us 121. But not the answer yet. So the answer will be the mean plus and minus this value. And now this is the answer. Now for the last one, we want to know what is the approximate sample size based on the confidence interval. And that is given by knowing that the confidence interval has this lower limit and this upper limit. You can compute that the margin of error will be the difference between the upper limit minus the lower limit over 2 by definition. And this is 0.03. So if I know that this is the margin of error, I can find what is the value of p, the proportion used to find the samples or to find the confidence interval, as this one here, for example, is the proportion minus the margin of error, which means that the proportion here was given by 0.85. Now that I know this, I can go back to the calculation of the standard error for proportion to find what is the sample size that gives us this value here, right? So in this case here, we have a 0.85 times 0.15 over here, what we consider to be our value of n, okay? So in this case now, our margin of error is given by 0.03, which including the 0.03, we have the standard error. So what we have is, so the margin of error here is given by definition the standard error times the z that we should use in terms of the confidence level. And for 95%, this is given by 196. So this means that the standard error will be 0.03 over 196, and this is 0.0153. So the standard error is that square root over, which is given by p hat 1 minus p hat over n, and this is 0.0153. And then what we need to do is just finish solving this for n, which will be this square is n. So n is 544.66, and we always round up this to the next whole number, so the answer is 545.